Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to be talking about Unit 6, Lesson 7, Isosceles and Equilateral Triangles. In this lesson we are going to prove several key theorems about equilateral and isosceles triangles, and then your work in the lesson is going to be largely algebra based. There's not a lot of proofs here except for the theorems themselves, and you'll see those theorems on the tests. We got four big questions to answer today. The first is that if two sides of a triangle are congruent, like you see in the picture here, are the angles opposite those sides, so these angles down here, also congruent? Now, if we know that those angles are congruent, does that mean the sides are congruent? What if this is an equilateral triangle? All the sides are congruent. Does that make the angles congruent? And suppose it's an equiangular triangle. Does that make the sides congruent? All right. Now, before we start answering those questions, we have to remind ourselves of some things. The first here being that in hypotenuse leg, the key is to first show that we have right angles. You don't have to show they're congruent, you have to show that they're right. Then we have to show that the hypotenuse of each triangle is congruent and that the legs of the triangles are congruent. Okay, now, if we can do that, we can prove that the triangles are congruent by hypotenuse leg. Opposite sides. The side opposite an angle can be figured out by drawing an arrow from the angle through the triangle. That arrow will point to the side opposite the angle. We can do the same thing for a side by drawing the arrow through, and it will point to the angle opposite the side. This is a very important concept, especially in second semester when we're doing trigonometry, but it's also important now and when we're doing triangle inequality. So opposite sides and opposite angles. An altitude is a line segment that is drawn perpendicular to the opposite side. So if I take from angle B and I draw a line segment so that it is perpendicular to AC, this line is an altitude. If I do this from all three vertices, they will cross all at one point, and that point is called an orthocenter. More on orthocenters later. The big key here is that every altitude is perpendicular to the side that it intersects. Now, the orthocenter doesn't always land inside of a triangle. Sometimes we can draw an altitude, like here from Z. We can draw the altitude perpendicular, but when we try to draw the altitude from X, we cannot get a perpendicular line inside the triangle. That perpendicular line actually exists outside the triangle. So what we end up having to do is we have to extend the sides of the triangle. I'm going to have to extend two sides here. Okay, and then we can draw the altitudes. And notice that the altitudes are still going to intersect more or less in the one point. I know this one doesn't look very good, but oh well. And that point is also the orthocenter. Okay, so the orthocenter doesn't have to be inside the triangle at all. It can actually be outside the triangle, but we still have right angles formed by the altitudes. Okay, so here's our first question, our first theorem. If two sides of a triangle are congruent, are the angles opposite those sides are congruent? So we know that AB is congruent to BC. The question is A congruent to C? To find out, we draw the altitude from B so that it intersects the side opposite at a right angle. So here we have right angles. Okay. The hypotenusae are congruent. Okay, that's not even a word. The hypotenuse of each triangle is congruent to the other because it was given to us. We also have the reflexive side BD. Okay, D being the point where the altitude intersects. So this is a right angle. We say that angle ADB and angle BDC are right angles because of the altitude. Now, the hypotenuse, AB, is congruent to BC because it's given. And then the leg, BD, is congruent to BD by the reflexive property. This means that triangle ABD is congruent to triangle CBD by hypotenuse leg. All right. Now, real quick, when we name the triangles, it's very important that you're careful how you name them. I went outside, top, bottom for ABD. So you have to go outside, top, bottom for the other triangle as well, CBD. Okay, so be careful. If you scramble the letters, you're going to lose a point on your proof. The other thing that keeping the letters in order does for us is, remember how we wanted to show that A and C were congruent? Well, look at their positioning. A is the first letter, and so is C. So angle A is congruent to angle C by corresponding parts of congruent triangles are congruent. So CP/CTC, which is the theorem we use to say that parts of corresponding shapes are congruent to one another because the shapes are congruent to one another. So this proves the isosceles triangle theorem, which is also called the base angles theorem in some books. All right, it depends on what you're looking at, where you're at on the web, or what book that you're using in your class. It's either called isosceles triangle theorem, or ITT, or it's called the base angles theorem, or BAT. You can call it either one you want. It doesn't matter to me. Just make sure that you understand that if you see it somewhere else, that you recognize that these are the same name for the same thing, or different names for the same thing. Okay, the second question was the reverse of that. Basically, if two angles are congruent, are the sides congruent? So knowing that A is congruent to C, does that mean that AB is automatically congruent to BC? All right, we're going to draw the altitude again. All right, so from B, we draw an altitude. Place point D at the intersection. This creates right angles, as expected, and the reflexive side. So if you look, we now have angle, angle, side, angle, angle, side. All right, so A and C are given to us. Angle A is congruent to angle C, given. Now we have angle ADB congruent to angle CDB, because the altitude generates perpendicular lines, which generates right angles, which are congruent. So I just say because of the altitude. Altitudes create perpendicularity, which creates right angles, which creates congruence. So ADB is congruent to CDB. Now the sides are BD congruent to BD by the reflexive property. So triangle BAD is congruent to triangle. Now remember to be careful. I went top, outside, middle. Top, outside, middle. BCD by angle, angle, side theorem. So now I want AB congruent to BC. And look for a moment here. AB are the first two letters, so are BC. This means that BA is congruent to BC by corresponding parts of congruent triangles are congruent. All right, so now we got some math. Here we know that angle B is 100 degrees. We want to know what the measures of angle, that's interesting. This should probably say angle C. We want to know what the measures of angles A and C are. Well, since this is an isosceles triangle, AB is equal to BC, we know that the angles are congruent to one another by the isosceles triangle theorem. So if I call these x, then 2x plus 100 is equal to 180. 2x is equal to 80. X is equal to 40. That means that the measure of A is 40 degrees and the measure of B is also 40 degrees. Okay, so what does it mean to say that a triangle is equilateral? Basically, it means that the three sides are congruent to one another. AB is congruent to BC is congruent to AC. Incidentally, it also means that we have several versions of isosceles triangles. So triangle ABC is also isosceles. It's isosceles this way, it's isosceles this way, and it's isosceles this way. Just depends on your perspective. Okay, so in an equilateral triangle, are the angles congruent? So we want to know, are these angles congruent to one another? We use the isosceles triangle theorem to do this. I know that AB is congruent to BC because the triangle is equilateral. All right. AB and BC are congruent, which means the angles opposite those sides are congruent. Angle C is opposite AB, and angle A is opposite BC. So angle C is congruent to angle A by the isosceles triangle theorem. I also know that BC is congruent to AC because we have an equilateral triangle. Well, the side opposite B, or the angle opposite BC is angle A. The angle opposite AC is angle B. This is the isosceles triangle theorem. So C is congruent to A, and A is congruent to B. That means that angle C is congruent to angle B by the transitive property. So are all the angles congruent? Yes, they are. And this is the proof. So, what if I say that ABC is equiangular? What does that mean? Of course, it means that A, B, and C are all the same measurement. Okay? So all the angles are equal. Angle A is congruent to angle B is congruent to angle C. All right? So that's what it means. Whoops. Does that mean that the sides are congruent? So if it's equiangular, does that mean that the sides are congruent? Well, if I start by saying that angle A is congruent to angle C, because the triangle is equiangular, then I can use the converse of the isosceles triangle theorem to say that BC, which is opposite A, is congruent to AB, which is opposite C. This is the converse of the isosceles triangle theorem. I can also claim that angle B is congruent to angle C. This is because the triangle is equiangular. B and C. That in turn means that side AC, which is opposite B, is congruent to side AB, which is opposite C. This is again the converse of the isosceles triangle theorem. Since AC is congruent to AB, which is congruent to BC, AC is also congruent to BC, transitive property. And this means that all the sides are congruent. So in an equilateral triangle, all the angles are congruent. In an equiangular triangle, all the sides are congruent, which basically means that an equiangular triangle is equilateral, and an equilateral triangle is equiangular. All right, so how do we do this? Here we have a triangle. The two angles here are 60. We can add those up and subtract from 180. We know the other angles is also 60 degrees. So why is AB congruent to BC? Well, that's the isosceles, well, it's the converse of the isosceles triangle theorem, which means that 3x plus 10 is equal to 5x minus 7. 17 then is equal to 2x. So x is equal to 8.5.